Hello everyone, and thank you very much for joining me again. Today we continue our discussion on JPA and Hibernate, and we discuss about JPQL queries. So we start a new big section of our playlist, and I'm pretty sure you'll enjoy it. And it's one of the maybe most used parts because I know we started with plain things like the operations of the entity manager, how to manage the context, and I've shown you how to design your object models. That's pretty important, and you use that with any kind of application where you use a JPA implementation such as Hibernate for your persistence layer. Regardless if you use also an application framework such as Spring or not, we will have to discuss about Spring, and I will show you how it integrates with JPQL with JPA implementations at the end, somewhere at the end of this playlist. Up to that point, I will keep it plain. But you know, one important thing is understanding how to model the objects, and then the second important thing in my perspective is understanding how to query it. Because a big part of the operations that you will use when you use an application framework such as Spring are hidden somehow, and it's essentially you understand them. So you know it's not only persist, you know it's merge as well, you know it's remove, you know it's refresh and everything that we have discussed, but you will very often see them abstracted using things like Spring Data and stuff like that. But queries, well, you will never escape having to write queries. So one of the important things is we need to understand deeply enough is how to write the queries. So we first start with understanding JPQL, Java Persistent Query Language. So it's kind of an adaptation of the SQL, but for objects, for the objects in the context of a JPA implementation. And then we will discuss about criteria queries. So yeah, let me share you my screen, and I'm just going to start by example because I know you like that, guys. And for these kinds of queries, my advice is you start watching this episode when you are comfortable enough with SQL, and I will try to explain the queries, but I will somehow rely as a prerequisite that you already know the fundamentals of SQL 92, the standards, and how to write simple SQL queries. And remember what I'm saying. So using Hibernate or any other JPQL implementation doesn't save you from learning very well SQL, native SQL. While native SQL is rarely recommended to be used with a persistent layer designed as an ORM, you need to know what happens behind the scenes. And remember that whatever we do here, whatever we write, whether it's the call of a persist method or a refresh method or a merge, or it's a query that we write, everything translates behind the scenes in a native SQL query. And you need to know SQL pretty well because you need to understand what the framework does behind the scenes. And in case you don't do that, you know what happens? Sometimes maybe the way you write the code generates more queries than needed. Maybe it creates non-performant queries. And if you don't understand the queries created behind the scenes, then you will never understand very well how to optimize your solution. So using any JPA implementation doesn't save you from learning SQL very well. One of the things any developer should learn, regardless of the programming language and technology they use, it's SQL. Okay, I'm referring here to backend developers. I can understand if you're a front-end guy and you only stay on the front end, maybe you don't necessarily need to know SQL. But if you're a backend developer, I don't care if you're using Python, Java, C#, C++, or anything else, you should learn SQL. And using frameworks that abstract things doesn't save you from learning SQL either, okay? So with that being said, I hope I made myself clear. Let's try to create a very simple entity, put some data, and then try to play a little bit with that data. I think we will not need for at least this lesson to have anything pre-generated, I will start with creating a table manually. It will be a very simple table, no relationship for the moment. We will dig into relationships a little bit later, maybe next time when we meet, and we'll probably discuss joins at that time. So when learning the syntaxes you need to know for joins, then of course you need to have some relationships because you need to have to join something, and that's when we will go back to relationships and everything we've learned about them. Also at that point will be important to remember what an unidirectional and the bidirectional relationship are. But let's start with the basic. Let's start with learning how to query a simple table and very simple things about the JPQL first before trying to go any deeper into any more complex syntax. So let's say we have product now. It's probably the simplest entity I could think about. Let's say that we have an ID, primary key, I mark it as auto-generated. We have a name, I will leave it a varchar, and we have a price, and let's say that this price it's a double, and it's something very simple. We don't need more than this now. So this is an empty table, and now I'm just gonna go here and I'm trying to manually add a couple of values that we can work with. Let's say we add a beer, let's make it cheap enough, and let's add a chocolate. Everyone loves beer and chocolate, I'm pretty sure, so let's add these two as our demonstrative records in the table. So I'm selecting them to make sure that they are in place, and you can see that the native select in my MySQL workbench returns the two, so we can now consider we have a table. So with that being said, going back, I've just copied the previous example we worked on. You know, I'm always doing that, and I've cleaned it up. So what I'm gonna do is manually at this time an entity. I will name it product. I don't need a table annotation since the class has the same name as the table, no product. So the only thing I need is to mark it as an entity. And if I mark it as an entity, then of course, let me just remember to also add it as an entity here. Remember, since we don't use an application framework, we need to manually list the entities as being through the managed class names, one of the alternatives in the persistent unit info. If you don't do that, of course, they will not be recognized. You don't have to do this with Spring or an application framework. You don't have this burden just because there is the application framework scanning the packages and doing that for you. But since we don't use any other framework, and I just remind you that this is a very plain Maven project where we have only added Hibernate, the driver, and the connection pool as dependencies. So you see, we don't use anything else. So it's just a very plain Java project with Hibernate. And it's the most important to, when you learn a new technology, try to isolate that technology from any other technology. So maybe I've answered this question in one of the previous videos, why we learn Hibernate without Spring here. Why do we do Maven projects and we only use Hibernate? Because, and that's an advice for all of you guys, when you learn something new, try to isolate it as much as possible and learn it first in isolation, because otherwise you will not know what the dependency does and what the other. So you will not maybe be sure if it's Spring doing something or Hibernate doing something. And I've seen this kind of confusion for so many times, people confusing annotations, confusing what's actually Hibernate and what's Spring data, because they simply started by using Spring data. Some of them start by using Spring Boot directly, and they have no idea what Spring does behind the scenes, and that Spring Boot is actually it's a project over Spring framework, and they simply believe that everything they see there is Spring. And as a professional, that's not really a way to go, because when something happens, you will have no idea where to go to debug that. So try to first learn things in isolation. That's the also the main reason in this playlist I started by putting a simple Java project and only Hibernate there. So what you are now extremely sure that what you see here, it's only Hibernate, no Spring, no other framework. And somewhere at the end of the playlist, when you are comfortable with all this, I'm going to also add an application framework, and then we will see the link between the framework that we've learned throughout the entire playlist, which in our case is Hibernate, and other frameworks that are essentials. Generated value, no, because I marked it as strategy identity. And we have so private string name, private big decimal price. Remember that always when you have something that is decimal sensitive, such as prices or anything where you want to make sure that all the decimals are well in place, you should never use double. You will see double being used in many examples, and developers use it because it's very simple. Now it's a primitive, or you may use the wrapper class. And of course, Hibernate knows how to map the floating number to double as well. It's very easy to use double, but it's not really practical. Remember that it doesn't offer you the confidence that the operations, being them even simple arithmetic operations such as addition or subtraction, you don't lose decimals. So big decimal is always better. It's always a recommendation in this case. Otherwise you will end up, especially if it's a sensitive value, with bugs where you'll have to search for a small, like a very small amount, and it will be difficult to do. You don't want to end up in that situation. Trust me, trust on my experience. Learn from others' experience, because it's always better than learning from yours. I mean, it's always good to learn from your mistakes, but it's even better to learn from others' mistakes. That's another very good advice that you should take from my experience. Cool. So I have the product. I hopefully I have correctly mapped my table. So I have ID, name, price, and I've used the correct types. And now if I'm going to go to main here, I have now the possibility to write queries. So I'm gonna write a simple query. Remember that one of the ways to write a query and execute it is using the create query method of the entity manager. And here we will discuss now only about the two that get a string as a first parameter. The other ones, they are related. So the named queries will be the following to discuss in this section. I will show you also how to write native queries, and I will explain you that in the majority of cases you don't want to do that. And I will also explain you when it's actually that exception where you can do that. And we will leave the criteria query at the end, and that's the large section of how to query with a JPA implementation. Yeah, and of course we could actually discuss also about stored procedures. Why not? So it's sometimes essential to also know how to call a stored procedure that is compiled on the DBMS level. But let's start easy today, only with the string queries, which get as a first parameter the plain JPQL. The first method here, the one that gets two parameters, having the class as the second one. You have seen me also using it in the previous lessons. If you didn't understand at that point what's everything, let's say, that I've done, starting today we discuss them in detail, so hopefully you will understand everything. And if not, remember, you can always ask me the questions. And I see your message, guys. Remember, if you watch the event live now, you have the live chat. I will stop in a while and answer your questions. If you don't want to watch the event live and you watch the recorded, you can still have you can still ask the questions in the comment section or leave your messages. And of course, remember, you can follow me on X and on LinkedIn as well. Yeah, this first that receives the two parameters is the most often used. You've seen me using it. This is the most often used today because it takes into consideration the type of the values that are returned. So if you use this one that has only one parameter, what you will get back is a query type, it's called. So we use the query interface here, and you can write a query, for example. So this is a query, I will explain it. But the problem is that being that you don't have any information about the type, whenever you will fetch this, you will have to write a mapping yourself, and we don't want to do that. So instead of using this method that gets that only receives the query but returns an object knowing nothing about the type that we query, we prefer to use the one that receives a second parameter. You just have to provide the type that you expect we will get, and then you see that it still works with query, but actually what you get is more than a query. In this case, it's what we call the typed query, and as the name suggests, the type query also gets also has a generic type, and now it knows how to map your values returned here into the object that you expect. So it's a lot more comfortable to use, and typed query is inheriting query, so that's the reason you've seen it working also previously, but it applies the generic types to all the operations, and it's again the way you would go with querying today if you use any query with a plain Hibernate app. So now the most simple of the operations is the get result list that you can call from the query itself, and then getting the result list, guess what you will get here? It's of course exactly a list of all the records that have been selected with, or let's name it products. Okay, and the reason we know the generic type here is because it's the one we have provided. So of course, in case it doesn't match, we will end up with an exception. And now let me also try to print this, like go through it and try to print all the products, say. And I will also add a toString method so that we can see it in the console nicely. And now I would like to focus a bit on the query itself. Actually, I would like to extract this query because I'm going to reuse a lot the rest of the lines of code, but I'm gonna change the query from now on a lot. So I'm gonna, oh, it's JPQL. I named it JPQL because it's not a normal SQL. Now take a look at the query. So normally, if you would have written a native query, it would have been something like select everything from product. No, so this is the projection. In our case, the projection is represented by the name of the instance you have given, and instead of selecting from a table, be mindful that product here is not the table, it's the object itself, the type from the context. So if in a native query, let's put them like this, if in a native query you would translate this as get or fetch all the columns from the table product, in this case you would say fetch all the attributes of the product entity from the context or from the current context. So you see the difference between having an ORM way of thinking and having an SQL way of thinking, no? So the translation of the syntax differences that you see between the queries is because you use an ORM way of thinking as well, and this is JPQL. It allows you to query the context, and as I always told you throughout this playlist, when you work with a JPQL implementation, you always think in terms of context and never in terms of tables, okay? You never select tables. Well, whatever you do, when you do a find, when you do a persist, when you do a merge, when you do a refresh, or whichever other operation I've taught you already how to work with, you work with the context, and then it's the framework's business, is the framework's duty to mirror the context whenever it's necessary, depending on what you do here. So if I'm running this, hopefully this would simply print both products. So in my case, all the records in the product table. And while this happens, let me also read what you asked me. If you asked me anything in the live chat, and trying to answer that. So why don't you make sprint in Hibernate JPA like the great sprint? I'm not sure what a sprint is in this case. I mean, I think you mean a marathon or something like that. Why not? Why not? I don't say no. So if that's the case, if you talk about a marathon, yes, I will plan this for the future. So let's say after finishing this, maybe I will find a Saturday or somewhere I can put the whole day and explain it from zero to hero. Okay, thank you very much for your suggestion. Then will you provide logging examples at some point in the future which contains bind variables? Yeah, actually, to see the values, because I think your question is, hey, I don't see the values here. No, actually, to see the values, you have only to add one more property here. And to be honest, I don't remember exactly the name, but I will find it because it's a pretty simple one. I never learned it by heart, no. But mind that you will not see them on the query directly. You will still see them separated, because behind the scenes here, this is added to a prepared statement, so you will not see the exact native query it goes. You will see the prepared statement followed by the values for each parameter. In case you want to see the whole query, what you can do is do some profiling for SQL queries. And to do that, I have already presented, you will find already a couple of videos on this channel about how to profile your application for queries. And why not, maybe in the future I will make it also part of this playlist just to be easier for you. But very good point, thank you very much. There will also be a video on JPA as services and repository structure. If you mean how to structure our application, yes, let's say that at the very end we can do that. But what I want is now focus on Hibernate, not on architecture, not on design, but on Hibernate and JPA. Because before you think about how to put your code in place, first of all, you want to make sure that you know very well how to use your framework. So I want to make sure that here I discuss JPA and Hibernate, and only at the very end I will add subjects such as logging, putting your app in a correct structure, and maybe integrating with other frameworks such as Spring. So they will come at the very end of the playlist. Cool. Thank you very much for your suggestions. And now going back, so you have seen it, it worked, okay? We've seen the query due to the parameter that we have used here, show SQL. We are also able to see the SQL that has been created behind the scenes. You see the native query. You can even go here and you can run it, and you should be able to see the same thing. Of course, it doesn't work here because it doesn't have the schema selected by default. So put a demo in front of it, and it should work. And you see it's working. Just that, of course, you see the very unusual namings that have been generated behind the scenes by Hibernate. So get used to that. Get used to seeing things like this. And you should, because whenever you implement any kind of feature, remember my advice: when you use something like a JPA implementation, do use the techniques you know to see the native queries that have been generated, and make sure that the generated native queries are according to what you expect to see, because again, it's a framework and there are chances that you misuse it. I don't say it might have bugs as well, because nothing is perfect, but from my point of view, Hibernate is quite a very good and robust framework, but there are still chances that you will make mistakes, because yes, we are human and we make mistakes. And one of the ways to prove that what you implemented is right is to verify that what your app communicates with the DBMS, it's exactly what you'd have expected. For example, you might see that there are not too many queries generated. You might want to see that the queries generated use some indexes that you expect to enhance the performance. You might want to see many things to make sure that the queries create the right result in terms of functionally, but they are also performant in terms of performance and non-functional requirements. Cool. And now the good news is that they basically they look pretty much the same with native queries. So once you've got the small differences and you put them in your mind, you will see that's very easy to translate between JPQL and a native query, or the other way around. So knowing then the basics of native queries, so knowing the basics of SQL, you will be able to do everything. So JPQL, and for example, as that's the next thing I want to show you, you might want to use a where clause. So the where clause works the same, and the same works the order clause as well. And you will see that even joins are very similar to what you've learned at the very simple SQL query. So I don't have any price of 100, but let's say that I want those that are greater than 5. So in that case, we should expect that only the chocolate will be displayed, because the beer has the price of 5. So this condition in the where doesn't fulfill, no? So very easy. And if I'm running this, I can prove that indeed my JPQL works fine. Okay, and here it is. And here it is, finally. Cool. One thing before, I'm talking now about select queries, no? And I think these are the most important, maybe the most used of them all. But maybe you will ask yourself, regarding the querying the data, can I also use updates, deletes, and inserts? And the answer is you can actually use updates and deletes, but no inserts. So remember that there is nothing as an insert JPQL. It only works with either select, update, or delete. And in case you want to produce an insert, the only way you can do that is by using the persist operation of the entity manager that we have already discussed and used throughout all the lessons. So normally we will discuss the select queries, because if you understand how select works, you will know how to write updates and deletes. And by the way, these are called batch updates and deletes. But yeah, the idea is that if you know how to write the select, then writing the update and the delete as a JPQL will be simple, because starting from the where clause on, you will basically use it the same way. So yeah, this is, and if you want, for example, you might want to use operators such as the AND operator. My OCD doesn't allow me not to do that. And you might want to say and name like something, okay? And I just realized that I have actually, because here I used 5. Now I wanted to actually explain the parameters. No, so of course the end is 1 point, so I could have written it this way. And let's put it all together in one query because I don't want to lose too much time explaining simple things. But you can use and or and even use parentheses to nest specific conditions. But if you want to use parameters, then this is the most used way to do that. And it's a name parameter call because you give it a name. And to be a parameter, you have to prefix it with a colon. And remember, the rule is never a space here. You should never have spaces here. You can have spaces here, but you can never have spaces between the colon and the name of the parameter. Otherwise, it will not work. So if you used it this way, then remember that you also have to provide values for these parameters. So you can use the set parameter, the set parameter method on the query to set all the parameters. So in my case, I have 2 parameters, and yeah, if you remember, you might want to use the like operator, which is also the case here. If you use the like operator, then you are also allowed to use the operators for prefix and suffix. And for example, this means what? It means any product that has a price greater than the value specified and the name containing the letter A. So containing the letter A because there can be anything before and anything after. You could have said, like in the normal native queries, I want all the names that end with letter A, or maybe I want all the names that begin with small a. It's your decision. So, and this works precisely like in native SQL, so I don't have to go too much into detail. Now, do I have anything that contains letter A and has the price greater than 5? Yes, I think chocolate matches both the conditions because the price is greater than 5, but it's also it also contains the A. So when I'm gonna run this, we should only see chocolate. And you can test that both conditions work, because if you will put like a 3 here instead of a 5, you will still see only the chocolate. And that's because beer doesn't contain an A in the name, no? Yeah, so even if I would put here a 3, and normally now you would think that you should also be able to see the beer because 5 is greater than 3. And while that is true, remember that we have chained these conditions using the AND operator. So it means that both conditions should be true for the record to be shown, to be fetched. And even though the price of the beer is greater than 3, beer doesn't contain the letter A in its name. So if I'm running this with the latest changes, we should only continue seeing the chocolate in the console. Okay, let's see it. And you see only the chocolate appears, yeah, because if you have said A, then it's fine, but in this case beer doesn't contain an A. And okay, that's one of the things, but now we have different things that we can fetch here, no? So let me actually put all of this in only one comment. So let's say something like I'm trying to make this look nice because I know I will actually share it now at the end, and then a lot of you guys, I know a lot of you are using my samples on GitHub to learn the things better. So that's why I'm gonna put this here in a big comment so you know what I did in a first example. Okay, in a nice way. And then I'm gonna go for a second example. Actually, I'm gonna move this up here too. And I'm gonna talk a bit about using functions because, okay, fine enough. So we know how to select the records and we know how to add a where clause to filter out records. But what can we do? What can we do further? Maybe it was actually good to show you something else before. So in one of the latest versions of Hibernate, and actually it comes from the specification itself, you can retrieve that as a Java 8 stream. So I'm pretty sure lots of you have used Java 8 streams, so you might be comfortable with, instead of get result list here, get result stream, no? So you can just take this as a stream of products. Okay. Why did I want to show you this is because there are so many cases where this is wrongly used. Remember, if you all ever find yourself writing anything but maybe a mapping after this, like if you find yourself writing a filter, okay, after this, ask yourself, why the heck didn't I add the filter here on the where clause and I'm adding it here? This is an anti-pattern. Never do that. So never get the values as a stream and then filter them in Java afterwards, because there is always a better performance to put them at the database management level rather than filter them in Java for both memory and CPU points of view. So I've seen this mistake of selecting all the records and then filtering them. No, if you want to filter something, you filter them in the query by using the proper where clause. You never get these as a stream and then filter them afterwards. And remember that most of the operations that you can do with a stream, sometimes, not sometimes, often I would say, they can be directly done from the query itself. And writing the query that executes those operations will always be more efficient than having to do them through a stream. So to be honest, I will always avoid this get results stream. I would actually use it only if I have a dependency that requires me to provide things as a stream. Because in most situations, whenever you get this as a stream, you get it to apply a function afterwards that can be better applicable from the query directly, where it would be more efficient from all points of views. So keep that in mind always. It's one of the advices I want you to remember very well. Okay, and now let me put this in a comment again. Okay, and the next thing is telling you a little bit about functions. So remember that arithmetical functions such as, for example, the mean, the max, the average, and so on, they are supported as well by JPQL. So when you need something like this, again, you don't need to go through a stream. So let me actually write some JPQL. And instead, I'm gonna say average of the price from product P. Yeah, you can use where clause, you can use a query as complex as you'd like. Now I want you to focus on these things as average, sum, mean, max, and so on, so you can use them. If you don't know which of these are supported exactly, you can always go to the specification. Remember that I've shown you the document. I always have it here with me, so you can just always go to the PDF specification you have seen in the first lesson, and then somewhere here, I'm not exactly sure where, but somewhere here you will find all the possible functions. Let me actually search it like this. Yeah, they should be enumerated, all of them somewhere. Okay, here they are. So you see many of them: absolute value, you have the average, you have these identifiers. They are not the functions, but I will just read the functions through all of this. You have the length of a string, you have the count, of course, you have the current date and timestamp. What else is a function here? Max, mean, and so on. Yeah, so you sum and so on and so forth. So I don't know the document by heart, but I'm pretty sure if you give it 5 minutes, you will find the section where all the functions are enumerated. And in this case, let's take average as an example. In this case, average of anything numeric you expect to be what? A decimal number. So yes, normally in this case you would use any type that provides with a decimal number. And I want to also put now here on the paper and show you another method to get the values. Is called get single result, because earlier we have used get result list. I think I've missed it. I'm missing it now. I deleted it when I created the stream, but it was something like, oh, after the parameters here, it was get result list. Okay. And now we are using get single result, and it's absolutely normal because what we select here is the average of all the prices that have been selected by this query. In this specific case, having no clause after product P, it means average of all the prices from the entire table. So in our case, being what, 5 plus 7 over 2, no, so it's 6. So I'm gonna get average and print it with the system out and run this. Okay, so and the same you can do to use any value. So you can, like, let's say this is a second example. Bam, bam. Oops. And then I'm just copying everything here because I'm a lazy guy, and I'm gonna show count of P, which means count all the products that have been selected. And in this case, it should be an integer, no, because the count will be a number of records, and in our case it will be 2, because being we haven't added any condition here, you will get all the products, and in our case there are 2 products. What is the difference between JDBC template and Hibernate? JDBC template gives me what I need. So why is the case that makes, so Mohammed, in case you haven't seen the first episodes, I do advise you to see those. I cannot answer this question here because it was already answered in the first episodes. This is episode 9, so it's lesson 9. If you will take the stream from lesson 1, you will see that I have answered the questions about Hibernate actually in exactly the first lesson. So my advice for you to get rid of all the things that are not clear, go to the first lesson and review it. And I described there in detail why would you use an ORM like Hibernate and not JDBC template. I hope that helps. Class cast, of course, sorry for this. It's actually a long always when you count. So my mistake. So I'm just changing it with a long, and I'm gonna run it again to see the value. So regardless of the number of records, the type of account is always designed as being a long. That's why I had a class cast. You know that also from the Streams API and other APIs that have a count function. Okay, so you can see how this translated to a native query with a count, and of course the result that you can see here is the 2. And again, I'm not going to take the sum, the mean, the max. I will leave this as a homework for you. Just try to when you get this example from my GitHub account, try to replace the count and the average with other functions and observe that they are working correctly. Good. So one of the things that you can do is selecting specific attributes. So I can write something like this. Let me actually, I will write it from scratch because I know I'm always lazy, but let me write it from scratch. So you can write something like select P from product P, but you can also, if you want, select only the name, for example. So you can either select all the name or maybe select specific values like this one, and then you can take this in specific objects. So you don't necessarily need to select all the values. You can take this as product as well, or you can take this as a map of values. So in my case, the type query, you see it in this case, it designed this as an object array because here you don't know what exactly object you have, so you cannot map it to a product anymore because it's not directly a product. So let's see in this case what happens. Okay, so you see from the array, the first value would be the name, and then the second value will be the price. No, so it just creates an array of objects, and then you need to know the types in that case. There are different ways in which you can get that, but this is one of them. Usually you will not use something like this because it doesn't offer a lot of advantages, but sometimes if you want to skip a relationship or something like that, maybe you want to skip something that is defined as being eagerly retrieved, and that is critical for the performance of the application, you can select. Remember that you can always select the fields that you want to select and only get those. And of course, what I will show you in the next lesson is that when you select from multiple tables, you can have the values from multiple tables and several attributes, but that's something I'm keeping for the next lesson because now we are almost at the end of this one and I don't want to put too much information on the plate at the same time, since this is not healthy for learning. But I'm gonna prove this, and after proving this, I'm going to talk a little bit more about the get single result, which has detail you need to know, and that is what happens, especially what happens when you don't find the value. So before that, take a look at the query that has been created and observe that indeed only the name and the price have been selected and not the ID. The ID is also a column, and normally it would have been selected if you would have written the query like this. You have seen that earlier in the same video that the ID was selected as well. But in this case, I demonstrated how you can enumerate and only retrieve specific values. And you can this way get even values like grouped functions. No, if you use a group by, you can do something like that. So, or maybe even here. So say I'm only getting the name and the average of the price, and then I have to group by whatever you find there. No, and I honestly love using text blocks, since I can do that starting with Java 17. Okay, I will do it like it once here. Java 15 actually. You see, so select the name and the price from the table, and then of course you have to group by the name since I have added it here in the selection list. And yeah, in this case you won't see nothing unnatural because there is only one beer and one chocolate, but the idea is that syntactically you can select stuff like that. So you can, for example, select the product attribute and then the value resulted by one of the functions like we did here. See? Again, very similar to the way you would have done this with a native query. Yeah, and if you really want to see something, what you can do is add one more row here and say 3 beer and 7. Yeah, and in that case now you will see that chocolate average is 7, but for beer the average is 5 plus 7, 12 over 2, 6. No, so you will see a 6 as being the average. Let's prove that. But again, this is not about the result, it's about looking at the syntax, and we will discuss, and throughout the next lessons you will see more and more complicated queries. Yeah, beer has an average of 6 because you have 2 beers and one costs 5 and the other one costs 7, and their average is 6. Chocolate is 7 because it's the only record. Makes a lot of sense, I guess. And yeah, before closing, and that's the last information for today, because I don't want to miss it because it's important, is we have used here the get single result. No, so somewhere here we use the get single result, and maybe you want to see what happens if you try to select something like, let me select a product that doesn't exist, where p name like what we don't have here, candy. Okay, we don't have any candy. I hope you agree we don't have any candy. So, and then of course you want to select products, and get a single result of the product type p and try to print the p, and unfortunately here we have an exception. Okay, so let's prove it. And this is not an exception because something doesn't work correctly. It's an exception because this is the way the get single result is designed to work. So the get single result will not return you null, and as you can see, it doesn't return an optional. The way it was designed is that if the query doesn't return anything, it throws an exception that properly tells you that nothing has been found in the database. So that's what we want to prove here, and how we work with get single result, because that's where I wanted to reach, is always if we expect that there is a query that doesn't or might not return something, then you need to properly use a try catch like this. Sorry for that. Okay, and then do whatever you want to do if there is no result. So you can do whatever you want. So I've seen even cases where this had to be passed somehow further. So what people did was optional of product P, and then you have P equals optional of the result, or P equals optional empty. No, you can do that if you want. Yeah. So yeah, it depends on what exactly you want, and then say P if present do something, or else do something else. Okay, you print it or you print no product. But remember this is important, an important detail. When you use the get single result, if nothing is found, an exception will be thrown. So make sure that you consider that. If that's not your case, you might avoid catching the exception, because the no result exception is a runtime exception. But in case you expect there will be a chance that nothing will be selected, then make sure that when you use this, you properly use the try catch together with it. Okay, the last session of questions, and then I think we can end the stream. So question: if I create multiple client application with one backend, should I use Hibernate or my bet is I don't think you choose one framework or the other depending on the architecture, or at least not only depending on the architecture. From my point of view, both MyBatis and Hibernate are cool ORM frameworks that you could use properly, and they cover similar use cases. So what I would do in your case is not choosing it by the design or by the architecture of the system, but I would choose it by let's say experience of the developers I have in my team. Do your developers know to work better with Hibernate or with MyBatis? That's the question. Do you expect that in the future you will find people who will know easier to work with Hibernate or with MyBatis? Try to answer these questions, and then depending on the answers, you choose one or the other. That's my advice. Love from Uzbekistan. Thank you very much. Send you all my love as well. And the last question: will there be a topic regarding dirty repeatable? Yes, I will cover this at some point, but if you are eager and you don't want to wait for it, I also have the same topic covered also in the Spring Framework playlist. So search it on the channel and you will find already a video or a couple of them discussing transaction isolation and how this affects the data consistency. You already find that. Thank you very much. With that being said, guys, I hope you enjoyed this first lesson. Oh, sorry. I think this one. The first lesson on the JPQLs. We continue next time with a little bit more complex things like relationships and joins between entities. We will make analogies with joins between tables, and of course we will then run also into more complicated queries like inner queries. Try to cover as much as possible everything related to JPQL and how to write real world queries, which usually happen to be on multiple rows. So they happen to be not as simple as at least the ones that I have presented in this lesson. So that's why we need to go further and discuss more. Thank you very much, and I hope to see you next time.